Okay, guys, I guess we get started. Thank you all for coming. I'm Jonathan. I work for Amazon Web Services in Berlin. Actually, I'm managing one of the services I'm going to talk about later on. And I'm here to talk to you about how you can run Docker on AWS. Before we start, maybe how many people used AWS before? So a good number, so I don't have to give the introduction. Great. How many people use Docker? Oh, like a very good high number. That's great. So hopefully I will be able to skip then the low-level introductions and kind of focus more on the interesting part for you. So that means I don't have to spend a lot of time introducing Docker, right? So we all know it and like it. And one of the whole points about Docker is, right, it's supposed to make things easier, right? So we can package things up pretty quickly, right? So here you have an example Docker file, in this case to create a Sinatra application. You can easily kind of ship your Docker container once you build it, right? If you have a Docker registry, for example. And it's also pretty easy to run Docker containers, right? That's the whole point about Docker. Why it's so successful and people like it, that it makes it very easy to create a repeatable setup and then hand it around, right? But things are getting a little bit more complicated if you think of how do I actually do this now on scale, right? The commands I showed you work fine on a single machine, but how do I coordinate this across a large number of instances? How do I kind of also, of course, reduce the work that I have to do? And that's kind of what the talk is about, right? Showing you how you can do this on AWS and what services we offer and what you can do yourself and kind of what are the options and what are the trade-offs there. So if you look at the offerings, there are quite a different ways to run Docker, actually. There is the probably most straightforward one for most people, which is this option. You just do it yourself by launching an instance, right? You get yourself an AMI with or without Docker pre-installed, and you launch yourself an Ubuntu or CentOS or a Debian or whatever, or Amazon Linux, and then you install Docker, and you just do the commands that I showed you, right? Problem is that doesn't work too fine if you have dozens and hundreds of instances. And how do you can of course create like golden AMIs that have everything pre-installed, but how you then you coordinate the rollout? How do you replace hosts that are dead in the fleet and so on? And that's kind of what most of the other services are about. And I want to cover today basically those options, right? And I will kind of leave this option out because in this world, it's no different than anywhere else, right? If you just treat EC2 as your platform in that sense, right? It's not different than if you do it on your laptop. You get an operating system and then it's your responsibility, right? So probably the most interesting thing if you're considering Docker is it's the service called ECS, the Amazon EC2 Container Service, which I will introduce in a minute. But that kind of gives you a much more streamlined Docker experience by taking care of managing the Docker daemon, by introducing a concept of tasks, definitions that you can use as kind of deployments, and so on, right? So that's the more sophisticated solution, but you still have to do a lot of legwork yourself. Then there's AWS OpsWorks, which is a more high-level management framework that uses automation to provide you with more convenience. And then there's Beanstalk, which is a much more simple and streamlined experience, but it's a little bit more limited in what it can do. And depending on what your needs are, right, like you can see there are different grades between how much control do I have, how much can I customize it, how much can I define myself, versus convenience, which is kind of the other extreme in terms of Beanstalk, right, which the idea is much more you give us a Docker container and the rest is taken care of, but that also means you're less flexible in how you define your application. And in general, those are kind of the trade-offs you can think of, right? If you would split it kind of in the more layered approach, right? If you look at what do you need to deploy an application, right? You have the host system, virtualized or not, right? You have the operating system, you have the language interpreter, you have like the service, and then you have the actual application framework maybe, and then you actually have your code, right? If you go the EC2 route, you need to own all of this. Docker encapsulates some of that part, right? But you still need to maintain the lower levels. ECS automates the Docker part, but still, like you own a lot of more of that. Where if you look at Beanstalk, basically in the Beanstalk world, you would just give us the Docker container, just give us the application code even. for some of those solutions and don't have to like invest time to manage the stuff below. And depending on where your comfort level is, depending on what your needs are in terms of, I need to really define this is exactly how the Apache config will look like, or I need to really define this kernel that I want to run on, and I really need this version of Docker or not, right? Like one of those options might be the right one for you. So let's start with ECS, right? That's probably the most fundamental service if you think of Docker and AWS. How many people know what ECS is or have used it maybe before? Okay, so a much smaller number than the people who knew Docker and knew AWS. So that will be then new to some people. So the kind of large text slide, right, that is in theory the pitch, right, like reads something like that says it's a highly scalable and fast container management service that makes it easy to run and stop and manage Docker containers, right, if you have a cluster of EC2 instances. That's kind of the theory. What it actually does is it takes care of some of the legwork that you have to do, right? Like it takes care of managing and installing Docker for you and kind of orchestrating and controlling the Docker daemon. You have a concept of task definitions that I will show you later on that allows you to do deployments of services that belong together, right? You can say I have a WordPress container and I have a MySQL container, and they need to know about each other and they need to talk to each other, and I want to deploy them together as a unit, right? And then you can define how many of those do I want to run, what kind of needs they have in terms of disk, in terms of network, in terms of ports, and so on. It also integrates with ELB and has a concept of services that allows you to do like kind of a service discovery through ELBs and DNS. So it already takes care of a lot of those things. But you still need to manage the container instances yourself, right? Like you still need to bring it the data center in that sense, right? You still own the instance at the end of the day. If you look at an architecture diagram, right, which might look scary at the beginning, but bear with me. This is basically what it does. So you have a bunch of instances that are running in your account that you own in the various AZs, and sounds like I don't have to explain that concept, given that so many people are familiar with that. But the general idea is basically you bring ECS a bunch of instances where you install the ECS agent. And the ECS agent is then phoning home to the backend service and is then getting back the commands in terms of what containers should be running on this instance. And the ECS agent will take care of the installation and booting and stopping of the containers and so on, right? And in addition to that, you have an API where you can then define how many containers do I want to run, like what containers should be running on which instance and so on. You can define your own scheduler in that sense, right? You can define, like the API is pretty simple so that you can really define how many instances or how many containers do I want to run. But now we also have a built-in scheduler that also does some AZ spreading and so on. But the essence is basically you bring a container, you bring a task definition, and you bring a bunch of instances, and the orchestration of those is taken care of, right? So that you don't have to do all of this yourself. In addition to that, it has some other features, right? Like it features a registry, so you don't have to use the public Docker registry if you don't like to. This is something that we announced recently, and you can sign up for. And of course, it integrates with IEM and the usual concepts and so on. But what probably the most important message here to remember is it has a registry, which is a private registry, which stores all your containers encrypted and so on. You can, of course, also use the Docker registry with it, the public one. It supports AZ-aware scheduling, right? So you can, for example, say for a certain task, balance it across my AZ. So if one AZ is down or one AZ has networking problems, for example, your application is not impacted by that. You can like define your own scheduling if you bring some code in that sense, and then just call the APIs for the actual scheduler. It's pretty simple, and a lot of customers are doing things on top of that, right? It's meant as a pretty low-level API. It also has a CLI that you can use, and I think it's probably a little bit hard to read, but you can kind of integrate with Docker Compose, right? And this way control the cluster and control the Docker deployments. And it makes, of course, local development way easier. And also something that we recently added is you can have much more control over the actual Docker configuration and so on in the JSON description of a task, right? So you can define things like Docker labels and host names, and you can request the privilege execution and all of those things. In the end, it's kind of automation around the Docker daemon, right? If you look at the actual instance, you will see the ECS agent and you will see Docker running, and the ECS agent is taking care of that integration. And as mentioned, that's probably the bare version you want to use if you're interested in Docker and don't want to manage Docker yourself, and you're interested in running it on AWS, right? But you still have to do a lot of legwork yourself in this world. It's an awesome service, especially for more advanced users. But the two options I want to talk about now make it a little bit easier for you, and I will show you like kind of how they support Docker and ECS under the hood. The first one is Elastic Beanstalk, right? So Elastic Beanstalk is a very simple management service to deploy applications, right? And it's very much focused on web applications, very much focused on providing you with a full framework where you just have to bring your code, right? And that's, I think, the big difference to the other solutions here. It supports various platforms, as you can see, .NET, PHP, Java, Ruby, Python, and so on. But it also supports a generic Docker container, right? So you can bring a Docker container, no matter what's running on that, and make it work. The general idea here is you should be just focusing on bringing your code, and then Beanstalk is taking care of the rest, which is awesome if you don't care too much about the rest. If you have more sophisticated needs, you might want to consider some of the other options. So maybe just briefly introduce to you some of the concepts of Beanstalk. So the idea is you can have application environments, and you have kind of versions of your applications, right? And then you can apply configuration templates to that. That's the basic idea, and then you can have multiple versions of that. I have actually a picture, I think, that explains this a little bit better, which is this one. So you can have multiple environments, right? Like think of that, the testing environment, the production environment, the staging environment, and so on. And each environment has a different configuration in terms of number of instances, does it use an RDS database or not, and so on. And then you have applications and different versions that you have to upload that then you can deploy to it, right? And as I said, those application versions can also be Docker containers. And then Beanstalk takes care of providing you with the actual runtime environment, which means the operating system, in the case of, let's say, you're deploying PHP, in the case of providing you with the PHP installation and the configuration of that, there is a configuration language called EB extensions that you can use to customize that. But it's pretty much optimized for a certain purpose, right? Like if you're deviating from it too much, it will get harder and harder to apply, right? But it's ideal to deploy a very simple web application. It also supports kind of worker tiers and so on. You can deploy using this console CLI, and we will have a look at it in a second. The general idea is basically you bring your code, you select a region, you select, okay, what is kind of the stack type I want to deploy on? You can say, do you want a single instance or multi-instance installation behind the load balancer? And you can define if you want an RDS or not. And that's pretty much it. Right, and it probably took me longer to talk to you about what it is than it will take you to actually use it. So with that, I just want to give you like a brief idea of what does it mean to run Docker on. Let me actually exit the presentation here. So if I want to run Beanstalk with Docker, it's pretty simple. Right, this is the Beanstalk console. You're creating a new application. Let's say we call it DevOps Con Demo, right? And then you can add the web server environment, and basically here you can already see I can add a Docker container, right? So Beanstalk supports all of those pre-configured. They were actually called containers before Docker came along, funnily. But the general idea is you can either use kind of a pre-configured environment, which you can think of, it's an AMI that has all of this runtime pre-installed, and you just bring your application. Or you can use Docker to run that. In the case for those three here, it's pretty much, it just uses Docker as a means to pre-configure your application. Sorry, the AMI. The more generic Docker one that you want to use are those two here, where this one is a single Docker installation, right? Like you bring just one container and one instance, which brings you the benefit of the packaging and the benefit of the deployment and the kind of that you can reproduce your local setup on production, but it doesn't maybe have the scheduling and the orchestration and the scale that you might care of. In that case, what you're after is the multi-container Docker version, right? Which means you can have multiple Docker containers on single instances and multiple instances and so on. Like, let's say we want to deploy a Python app. Basically, you just define that, right? So this is now using the Docker container, and as you can see, it's pretty much optimized for the simple application world, right? So in this case, I could deploy my own Python app, or I'm just picking an example app here. That's pretty much it, right? If I would like to use a database, I could tell it here to also use one. And then I can pick the instance type. I can pick like the SSH key I want to use and some auto-scaling configuration. But if we ignore all of those defaults, we're basically just launching it, right? And this is the configuration I would use. And then I say launch, right? And this will launch an instance that has Docker pre-configured for me. Inside the Docker container, it's running a Python Flask app. And then now I just need to bring my application, which will be deployed into the Docker container to run it. And now it will boot up and so on, right? So I don't want to spend too much on that, but that should give you hopefully an idea of if you're interested in a very simple way to deploy Docker containers. And obviously, if you have a ready Docker container that has all your application framework in it, you would have chosen the either single container or multi-container version. But that's pretty much it, right? Like in this case, I don't care too much about the operating system. Why would I if I use Docker, right? That's one of the points. I don't care too much about the architecture, right? I just want to say I have some form of web application behind an ELB, and the rest is done on my container. Then Beanstalk is great, right? And Beanstalk offers you some additional monitoring and alarms and logs and health checks and so on. Yeah, so this is one of the possible worlds. The use case that is more optimized to somebody who doesn't want maybe to be bothered with too many details. If we kind of continue that, so that means that for that world, right? Like as I said, we have multiple Docker options in Beanstalk. You can say I want to have a single container, I have multi-container, or you can use those pre-configured Docker containers and use those to get started. Now, the drawback here is, as I mentioned, right? Like you don't have the full control over this environment. What is if you want to, right? Like then you can use ECS. You can also use ECS in combination with OpsWorks. And I'm a little bit biased because I'm working for that team, so like I will focus a little bit more of my time here because I'm also more familiar with that technology. But I think that this is a very good combination because it allows you to use one service, ECS, for the Docker deployment and the Docker orchestration, then use OpsWorks for managing the actual container instances and the infrastructure underneath, right? If you a good analogy is maybe, right, like one idea behind Docker and kind of one vision is to say, wouldn't it be cool if you were able to say, in my company, I actually have a team that provides the actual infrastructure for my developers in terms of they provide a pool of instances that can run Docker, and they manage those instances, right? And then you have the application developers who don't need to know anything about that world. They just give they just produce a Docker container and then just deploy it onto that virtual Docker data center in that sense, right? So that's like a very, I think, interesting vision that allows your developers to be very productive because they just produce a Docker container, right? But in that world, which is funnily a little bit different from the original DevOps idea, right? In that world, you have like two very different responsibilities and two very different needs, which I think you can actually model very nicely with ECS, which is assume you have this infrastructure running, you just deploy Docker containers, and then the OpsWorks world, which is about operating the actual instances, providing Docker as a service to you in that sense, right? And hopefully, like this will become more understandable as we progress here. So. If we're interested in doing this, how does it work, right? Maybe a first thing to understand is that what does actually OpsWorks do in order to help me to run Docker, right? So the general idea in OpsWorks is we help you to manage your infrastructure by grouping it into what we call layers. You can think of them as tiers maybe, or groups of servers, right? The idea is you have a bunch of machines that should have the same kind of configuration in terms of they should have all a certain volume attached. They should all have elastic IPs or not. They should all have a certain security group, or they should all have certain packages installed, like, hey, maybe a certain version of Docker, or certain tools that you need, or certain people should have access to them or not, right? And all of this configuration you can apply to a layer, and then you can define how many instances should be in a layer. In the classical pre-Docker world, this would have been, you have maybe a load balancing layer, and then you have an application layer, and then you have a database layer, and each would be running directly on the instances, and then you have those different configurations. In the Docker world, probably you have a single layer, which is run Docker, and then you do all of this per kind of type configuration within the Docker container, right? Like you would have a Docker container for your application server and a Docker container for your database, for example. But the concepts are pretty much the same. And once you have this per layer definition, you can apply, as I said, configuration. You can use kind of the AWS side of the configuration, like integration with ELB and EBS and EIP and so on, or you can use software side integration with, in this case, Chef, to define the configuration of the container instances, right? So this is done because OpsWorks is embedding Chef for you. So in that sense, you have kind of two sides of it. OpsWorks on the one hand is taking care of the AWS integration, right? Like launching and managing my actual instance. So in that world where I want to have this pool of instances being able to run Docker, you want to define how many should there be, right? And if there's an instance broken, I want it to be replaced. I want to use auto-scaling to launch more instances if I have the need to, and so on. And this is what the OpsWorks backend is taking care of. And then there is the OpsWorks agent that is installed on your instance that then takes care of the actual on-instance configuration, right? So the idea of I need like Docker installed, right? I need like Vim installed and HTOP, and I need certain tools installed so that if there is ever a problem with my Docker container instance, I can take care of that and I can configure that and so on. So, or I want to deploy a security patch to all my container instances, right? Or I want to replace them and so on. So, so that work doesn't go away if you use Docker, right? Like it's just hidden to the developers who just deploy a Docker container, but somebody still has to take care of the actual Docker instance or the container instance, and that's what this tool will help you to do. So, let's say you're doing actually like a deployment. So how this happens is you would do kind of a command that is represented by JSON. This will be sent down to the actual instance, unpicked by the agent and executed. And then the agent is picking it up and sending it up to the backend. All of this is happening because the OpsWorks is kind of packaging Chef for you for that on-instance configuration. So that's way how you can do this. It's a little bit different than Chef server. Like there isn't a Chef server like it's done by in that sense the OpsWorks backend instead. But you can think of it as very similarly to a typical Chef server. And it supports different versions of Chef. The idea here is basically you should be able to control how the configuration of the instance looks like, right? This is not inside your container, this is outside of your container. So that you can manage that, and I will show you in a minute how this actually works. OpsWorks has some additional features to that, but I think we can skip this for now because we don't care about that particular world of it too much. So let's actually have a look at it and see what does it mean to use Docker with ECS together, and also by doing this we will have a look at ECS. So so this is the OpsWorks dashboard, right, where we can create a stack. So let's create one. Let's call it again DevOps Con Demo. Right. You can pick kind of the typical settings that you use from EC2, right? Like the region, VPC or not, and so on. If you use ECS, by the way, it has to be in a VPC. You can define SSH key so that you can actually log in, and so on, right? Like so in this case, I'm just creating this. I don't care too much about the other settings, and now I need to create the layers, right? Originally, I would have created maybe like directly those application layers. In this case, I'm caring about an ECS layer. I want to add an ECS layer. I don't have any right now, so I need to create one, right? So let's create an ECS cluster, which is an ECS concept, which is the group of instances that should be running Docker for me, right? So now I'm in the ECS console. I'm creating a cluster. Let's call it, I don't know, demo cluster DevOps Con. And that's pretty much most of the configuration I have to do for now here. So in this case, I kind of select it now, right? I can override like an instance profile that I need. So if you're not familiar with instance profiles, this is kind of the permissions that are assigned to an instance that it can use to talk to other AWS services. So in this case, I want this instance to be able to talk to ECS in order to register itself with ECS and say, if I launch more instances in this layer, they should be able to talk to the ECS API endpoint. So I'm creating that layer. And here I can do kind of those settings that I mentioned, right? Like now we're talking, please remember, about the container instance, not the actual containers on it, right? So I can define kind of what packages should be installed there. For example, I could say that in order to manage that, I need htop, for example, right? Or I need Vim. In the end, this is just configuration that is applied through Chef to the instance. I can define a certain volume, like if I want the containers to have a volume provided by the container instance. Or I can define security groups, and this is actually something that we want here. So I'm adding a security group that opens port 80 and port 443 because I'm going to run a web application in my containers. And this way, every instance in this group will have the security group. And I also need to, because I'm running in a VPC and I don't want to use a complicated NAT setup, I want to say that every instance should have a public IP address so I can actually reach it from the internet, which is probably not what you want in a production setup, right? In a production setup, you would want them to be behind an ELB, an elastic load balancer, and not be directly accessible, but for the demo purpose, we will pick that. And as mentioned, yeah, you can do more sophisticated configuration here, but the general idea is, right, I define how should an instance look like, and now I can add instances, right? I can just go to this layer definition and pick an instance type. So override the subnet, override the IP address, the OS, and a couple of other things. For now, we'll just keep the defaults and launch it, right? And this instance will then, let's add a second one. So those instances will now boot the operating system that I selected, in this case Amazon Linux 2015-09. They will install Docker and the ECS agent, and they will register with the ECS cluster that I connected this layer to, right, which is this guy here. So in a couple of minutes, the instances will show up as registered instances. At the moment, there aren't any, but there will be those two instances showing up soon. And then we'll do whatever I said on the ECS side, right? So in this case, we're now, in this console, in a sense, we're building the data center view for my developers who want to run Docker on top of it, right? So we're defining the instances. We can define the configuration. I can add more instances, remove instances. I can show in a minute how to do auto-scaling and time-based and load-based. With that, we can monitor those instances. So that's kind of the ops view on my kind of low-level Docker cluster. And then there is maybe the application view, which is this side, which is given I have a certain pool of instances, how do I now deploy my Dockerized applications on it, right? So let's do that. In order to do this, there is a concept in ECS called a task definition. So let's create a new one. So let's call it WordPress demo. And I'm going to define it via JSON. So basically, this is the JSON template, the wrapper definition language around. You can think of it basically as is a templating around containers. So we define, given a certain container and a certain other container, how many of those do I want to run? Should they be able to talk to each other and so on? I'm going to use an example from the documentation here that runs the famous WordPress example, right? So let's change it also here to WordPress demo. So as you can see here, I'm defining two container environments, right? One that is using the WordPress image and one that is using the MySQL image. I define that the WordPress image is exposing port 80, and I'm also defining that how many CPU and memory units I want to apply to, right? And I'm defining that there should be a link between those two. And of course, you can do it a lot more complicated. There are a lot more options available, but that's kind of the very, very simple version of this. And this is the now ECS configuration of a task, right? And of a task, you can think of it as I want to run a certain my application, right? And you can have versions of those tasks. And when you, let's say, you build a new version of your WordPress container, usually you would create a new version, a new task definition version that references probably a different image, right? Like a versioned image, where you have in that sense golden images, golden AMIs, golden container images. And now you're referencing a new one. You would deploy this new task definition to your ECS cluster. So I'm saving this and creating that. And as you can see here, for my task, I see that there are 2 containers running WordPress, or I want for it to run 2 containers, WordPress and MySQL, each with 10 CPU units, each with 500 megs of RAM. And you can also define additional volumes that should be available. Like for the MySQL case, it probably makes sense to assign it a volume, right? Because you want your data to be persisted. And you can define some attributes and so on. If I go to the cluster, the instances are not available yet. They will be in a second. You can see they're running, they're set up. We can have a look at it in a sec. Then we're probably going to add like a service on it, right? So in this case, I can select the cluster, I can select the actual task to run on it, and we can say, now this is the service we want to provide, so let's call it the actual WordPress app. I want it to run on kind of 2 tasks, for example. You can add a load balancer, and now we can create the service, which will be applied to the instances as soon as they're available. Now, those instances, which are controlled by OpsWorks, are currently, let's log into one of them. They're applying the configuration that we just said, right? So, so let's make that a little bit bigger. So as you can see, they're applying the OpsWorks setup. There is a command line tool that will allow me to kind of watch the configuration that is happening through Chef at the moment. So it's installing the dependencies of the ECS agent and the necessary programs. If you watch it here, it actually installs HTOP, as you checked and maybe saw scrolling by. It's installing the ECS agent, as you can see right now, installing Docker, and setting up everything so that the instance actually looks like the ready instance I need. Of course, I can also package that and create an AMI of this so that I can save the time launching this, and I don't have to wait for this to complete, which it just did right now, right? So it started the ECS agent. So if we look at what's going on here, you can see there is an ECS agent running, right, which will runs Docker for me and does all the configuration that I need in this case. It will have HTOP running because we set it so, right? It will have Vim available. So basically, it will apply the configuration that we asked it for. So if we now go back to the ECS container, the ECS UI and look at our instances, we see that there are now 2 instances. 2 instances running, right? 2 instances that are active, that registered. We see which version of Docker they're running, which version of the agent, what their capacity is, and so on. So here, my instances are now fully configured and ready, right? And actually, if I would go to the IP address of one of them, we should be, not yet because it's still deploying, but should be seeing our the service right now, right? The service is active, so one of them should be in a minute showing us the nice WordPress demo app in a second. Yeah, if I want to add more capacity, like I now can do this on 2 fronts, right? I can add more containers, right? Which I would do through the ECS interface and APIs, which would be, I'm an application developer, have a new version of my app, or I want to increase the provision capacity, I would do it here. Or I want to add more underlying container instances, which I would do in the OpsWorks side of things. And as mentioned, you can actually do autoscaling. So let's say I want to add more instances if I have the need to, because I'm oversubscribed my CPU potentially, right? And the instances are using a lot more CPU than I originally thought. So I'm adding a bunch of instances that should only be running on certain conditions. So here it's pretty simple for me to define when should launch more capacity, right? So we have a couple of very simple metrics in terms of you can define the average CPU across all instances in this layer will have a certain threshold met, like average CPU, memory, or whatever, and the same kind of you can define for downscaling. Or you can just use any CloudWatch alarms, which allows you to tie it to more complicated things. Let's say your containers are actually working off a queue, right? You have like you're working off an SQS queue, or you have a RabbitMQ container, and then you have RabbitMQ workers, and they're working off the queue length, and you have a metric of the queue lengths that you're submitting once a minute. And if that queue length is ever bigger than X, launch more containers or launch more instances. And if it's ever lower than X, like shut them down again, right? So in this case, let's keep it simple and just use the average CPU. So we have now this definition going on here. So if I go to my instances, I see now I have 5 instances. 2 are running all the time, and the ones that I control, and 3 they're running only when when those thresholds are met, right? And I can also do the same thing for kind of load-based capacity. So I can say let's add a bunch of instances that are only running if there is a certain time of day met, which might be a good example use case is, let's see, this is your development cluster, right? Maybe you have a production cluster and you have a development cluster, and for security reasons or accounting reasons or for whatever reasons you're running them on different accounts, and then you want to say, hey, during weekends I actually don't need my development cluster, right? Because my containers don't have state anyhow, and hopefully nobody's working on the weekend, so I can shut it down and save money, right? That's one big appeal of the cloud, right? That I only pay for what I use. So I can define, you know what? Those are the times where I need more capacity, and this is the load pattern for whatever reasons for my application for my customers, and you can do this, of course, more sophisticated, and all of that is also available through the API. But this UI is maybe a nice way to show you that it's that easy to define. This is when you launch more capacity, and this is when you terminate it. And you only pay for the green colored bits of it, right? And what will happen now is OpsWorks will launch 3 additional instances for me. We'll do again the same dance of installing the ECS agent, registering it with the ECS cluster, and then the ECS cluster here will take care of actually deploying my instances onto it, right? Deploying my task definitions onto it. So we will see here in a bit that those 2 instances that are currently active here will become more as soon as those instances start up, which will be any second. The other thing I can do here is I can define who should be able to log into my machines, right? We said somebody has to administer those container instances. Ideally, you touch them very rarely, because the whole point is that most of your application is inside the Docker container. But still, there is a need to regularly maybe install a security update or check, are we vulnerable? Maybe look at some logs, maybe debug a problem with the Docker daemon itself. And as you can see, some of the instances are already launching up. So you can do this under this permission tabs here, which allows you to define who has access to this cluster at all, like in terms of the API, and also you can say who can actually log in via SSH or sudo capabilities to the instance. So in this case, I granted an IAM user access to it, and this IAM user will pop up in a minute. So at the moment, you can see it actually doesn't exist on the machine yet. But because I granted this user access, this user will show up in a minute or two, so that this is maybe one of the admins who should have access to the low-level container instance, where your actual application developers maybe should only have access to your actual containers. And ideally, you never even do that, because that's the whole point about containers, is that you have you produce them through automation, maybe through a CI/CD pipeline, and then deploy them and have kind of immutable infrastructure, right? But when things are not running as you expect it to, maybe you need to log in and verify that. So this is how you can then grant access to it, right? And yeah, so you can see here the instances are coming up as soon as there will be available, they will again register with the Docker container, with the ECS cluster, and deploy the task definitions that we defined. And if you have now at some point a new version of your task here, right? You can select a new version and can say, okay, let's create a new version of this, right? So let's say here you're referencing not the WordPress image, but we're actually referencing a different version of the image, right? So I'm not referencing WordPress, but I'm referencing WordPress v1.1, which would need to be available in my image registry, right? So at the moment I'm using the public Docker registry, but imagine I'm using my private registry. So this is how I would identify a certain release version in that sense, right? Once I do this, I would deploy a new task definition. And this way I would get like the new versions of my Docker containers running. And you can also imagine doing some form of blue-green deployments. If you do this behind an ELB, you would deploy additional capacity to your cluster. You would use a different ELB maybe, and then check out that everything works fine, and then do DNS swap of your ELBs, or even just reattach the ELB from one service to another inside ECS. So yeah, that's pretty much what I wanted to show you. Hopefully for the folks who were familiar with Docker on AWS, it was something new, and for those who weren't, it wasn't too advanced. So yeah, with that, I will be open for questions. Any questions? Anything I can help to clarify? Yes, please. Sorry? So the question is, what is the deployment button for? In OpsWorks, you mean? Or in, yeah, so OpsWorks also supports the kind of pre-Docker world where you run your applications directly on your instance. So in that sense, there is also an application model. It's very similar to in Beanstalk, where you had the Dockerized application model and the non-Dockerized application model. In OpsWorks, you can define yourself an application that should be deployed through Chef directly on the instance. You can also run certain actions this way with Chef directly on the instance. Let's say you need to restart the Docker container because there was a bug or something. You can use that to run a script on all your instances, on all the container instances. Any other questions? Yes, please. Yeah, so the question was, if I'm using Tomcat in my Docker container, can I still use the Elastic Load Balancer to load balance those? And the answer is yes. You can bind an ELB to a service in ECS. So if you go to a cluster, for a service, you can see here it has the load balancers part available, and I can bind an load balancer. I'm not sure if the UI allows me to do it, or you would have to use the API directly. But in the part where we define a new service, for sure, it's let me do that. So just to show you here that part, so you can see here, right? I can select one of my existing ELBs to bind to a container. So let's say I'm putting this guy, and then you can ask the container. In this case, it's already pre-filtered the containers that have port 80 or 443 open. So this is how you would do this, and then the ELB would load balance across all the containers running this certain image within a task that I have deployed here. So you're binding a task to a service, and then a service can be bound to an ELB, and then you would define, okay, this ELB should load balance to what container fleet within this task. So this way, externally you would just expose the ELB, and then internally it will load balance to potentially the thousands of containers you're running across the container instances. I'm not 100% sure, to be honest. I think session stickiness is anyhow a concept that in this world is not as easy, because you could have the kind of depending on how you use the scheduler, it might reshuffle your containers, right? But yeah, I'm not 100% sure. I would have to check with the ELB folks myself. Any other question? Yeah, if you don't have any more questions, then thank you very much. I hope this was useful to understand how to run Docker on AWS. And I hope you enjoy the rest of the day.